Hello there, and welcome to Hub Beyond Numbers, where we learn maths the easy way. Now we are still on rigid motion, and this time around we are looking at rotation. Rotation. So, what is rotation? When we talk of rotation, talking of rotation, we say rotation is a type of rigid motion, all right, that turns a shape around a fixed point. You see, and that fixed point we call it the center of rotation. The fixed point is called the center of rotation. So we're talking of a rigid motion here, you see, and then it will just turn the shape or whatever you have. Maybe it could be a point around a fixed point called the center of rotation. Now, these are the important things you have to note about rotation. Since it is a rigid motion, then you should always know that the shape does not change in size or in its shape, you see. So there's no distortion. The shape should be the same. It shouldn't change in size. And if you are rotating a square, it shouldn't become a rectangle. It shouldn't become whatever. Every point rotates through the same angle. So if you have more than one point on the shape and then you are rotating, at the end of it all, they should have all rotated in the same angle. And then finally, the rotation we are talking about, it can be either clockwise or anti-clockwise. Let's look at an illustration of all this we have written here. So take a look at this shape over here, this very shape over here. And I want to perform a rotation on it. So let me just highlight that, you see. And then highlighting that, if I want to rotate it over 90 degrees, it is going to be something like this, you see. But we said it should be on the fixed point. So if this is my fixed point over here, then I align it. This is how the rotation on 90 degrees is going to be like, you see. So that is what I have done over here. You see, it is just this, you see, and then I have rotated it over several angles. So just this figure over here, and then I've rotated it. So this here is going to be my 45, no, sorry, my 90 degrees. So let me just write that out. So this here is going to be a 90-degree rotation, you see. And this white one is going to be a 180-degree rotation. And this here is certainly going to be 270 degrees. And then its initial position is actually a 0, you see. But that is, these angles I'm given is when we are rotating in clockwise direction. You see, remember clockwise, that is following the arm of the clock. So if it was following the arm of the clock, this would have been the angle demarcations. But if it was anti-clockwise, then if I have my 0 degree here, anti-clockwise follows this direction, you see. So this here is going to be my 90 degree, you see. And then this white one is going to be my 180 degree. That is after rotating this. Then this blue one is going to be my 270 degrees. You get it now? Yes. So these are how we perform rotations. But I would be explaining how to do it arithmetically. That is how you can use formulas to do that. So without wasting much time, I'll just combine how to do 90, 180, and then 70 all on a table and then explain. Okay, so the table you see here is just a summary of the rules we need when we want to rotate around or about the origin in 90-degree, 180, and then 270 degrees. And for most at times, we usually work in anti-clockwise, you see. So I've written all of this here in what anti-clockwise angles. Okay, so in this table here, we do have the rules when we want to rotate about the origin. And as you can see, I have them for 90 degrees, 180, and then 270. These are the common ones we have to know for now, you see. If you're able to understand this one, you understand the rules. If we get to the graph and then I just add how to even do it without the rules, you'll be able to figure them out. So the first one here says if we want to As I said earlier on, most at times we want to work in anti-clockwise direction, you see. So if about the origin you want to rotate a figure 90 degrees, 90 degrees anti-clockwise, that is this way, right? 90 degrees anti-clockwise like this. So all you need to do is, if the coordinate of the point is x and y, then the rule here is saying that interchange the x and y value, but then negate that which is over here. What does that mean? So you have x and then y, and then you want to rotate it about 90 degrees anti-clockwise. So all you need to do is let's interchange the x and y value so that it becomes y and then x. You see, after which we negate the y value. If you're able to do this, then you can simply what? Rotate about 90 degrees. So for instance, if we have, let's say, a point. So point A with coordinates, let's say a 3, 4. If you want to rotate it about 90 degrees, sorry, about the origin in an angle of 90 degrees, then all it is saying is let's interchange the values so that we have 4, 3, and then we negate our new value, which is for x. You see, as simple as that. So rotation about 90 degrees, do what? Rotation of 90 degrees, do what? Interchange and then negate your new x value. Let's look at 180 clockwise. 180. Now you should take note that if you have your Cartesian plane, 180 clockwise is the same as 180 anti-clockwise. That is why over here for the direction, I have stated that either clockwise or what? Anti-clockwise. BC. So for clockwise or anti-clockwise, that is 180 degrees. If you have x, y, and you rotate it above this 180, all you should do is just negate both the x and then y values, and that is all. Negate the x value and then negate the y value. So taking the same point we used earlier on, A being 3, 4. If you want to rotate this about 180 degrees, then it is going to be what? A negative 3 and then a negative 4. You see, so once again, if our rotation angle is 180 degrees, it is just the same coordinates, but with negative signs. You get it? So that is just that. That simply means that if our coordinate was negative 3, negative 4, then if we have to rotate, it is now going to be negative of the negative 3 and then negative of the negative 4, which then becomes 3 and then 4. You see, so this also calls for you being able to work with your integers. Then the last one, that is anti-clockwise, 270 degrees. So for 270 degrees, it says if you have x and then y, and you want to rotate about what? 270 degrees, you should also interchange your x and y values. So that I have y and then x. Then this time around, we are going to negate this one here, the one that has become our y coordinate. You see, that is the formula over there, or the rule. How do we put this into practice? So if you have A with coordinates 3, 4, and you want to rotate it anti-clockwise 270, so we are going to interchange our values first, after which we do what? We negate the x, sorry, that is our new y value. You get it? Okay. So with this said, I wouldn't take points for us to work on as we have done the previous one. I'm going straight forward to take a plane figure, this time around a triangle, so that we work on it. So we do have our question here, which says you have to rotate triangle ABC by what? 90 degrees, 180, and then 270. We are doing all in one. So where our A has this coordinate, B has this, and then C also has this. We would solve everything down. If we finish, we go to the graph and then plot them out. Okay. So our solution. Now for A, whose coordinate is 1, 2, and then, or let me rather write it this way. We are going to work that of 90 over here, and then we have our 180 here as well, and then our 270 also over here. So A is going to be here, whose coordinate is 1, 2. Then B is also going to be here, whose coordinate is 4, 2, and then C, whose coordinate is 4, 5. Now I have shifted it to the right hand side so that over here I'll rewrite the formula so that it sticks in our mind. Okay. So for y, remember we said the rule is if you have x and then y, then all you need to do is to transform it so that it becomes negative y and then x. I hope you do remember that. These have to be memorized so that whenever you are working, you will be able to make reference without having to open books. So for x, y, also over here, over 180, we are going to get negation of the y value and then negation of the x value as well. Then our last one over here, if you want to rotate by 270, we also want interchange. So y and then x, and then we negate this one over here. So these are the formulas we want to use, right? So let's start with our solution. So starting with A, for the first one, which is the 90 degrees, so I'm just going to name them A prime. And it says we should interchange the values. You see over here, you have to interchange the values. So it becomes 2, 1. Then after interchanging the values, so let's negate the 1 that has come to occupy the x. You see, so I'm just going to negate this one. Same applies to our B prime. So we have to interchange our values. 4, 2 now becomes 2, 4. And then we negate our new x, you see. Then for C is also going to be 4, 5 becomes 5, 4. Then we negate this first one, which is the x coordinate. As simple as that. So this is rotation by an angle of what? 90 degrees. We are just applying the formula. Then we come to 180 degrees. So I'm going to name that A prime prime. You see, and that one it says let's just maintain our x and y. This our x and then y is the original coordinates. Let's maintain them, but let's do what? Let's negate them. So for B prime prime, it still says let's maintain them. That is our 4, 2. Let's still maintain them, but let's negate them. Then for C, let's maintain negative 4 and then 5, but we should negate them. You see, so if you know the formulas, it will just be very, very easy. Then for the last one, A prime prime. So this one says we should interchange. So instead of 1, 2, we are going to get what? 2, 1. And then we negate our new coordinate here, which stands for the what? The y. You see. Then for B prime prime prime, we are going to get interchange. So we have 2, 4, but let's negate the new y value. Then for C prime prime prime, we have what? 5, 4, but we negate our new what? Y. Now with this done, let's go to our graph sheet and try and then transfer this onto that. So this is our graph sheet here. And at this point, I would advise, if you are practicing along, which I do recommend you are doing, come back here and then write out your points. You see, so this was the initial point we were using, that is A, B, and then C, and then we'll come and plot all of this over here. Okay, so I do have mine. So, or better still, from time to time I'll come back here so that we'll look at it. So with that said, let's start with plotting of the point. So for our initial point, A was 1, 2. So we come here and then we locate the 1, 2. 1, then 2. I have that over. Let me zoom in so you see what is going on. Okay, so A was 1, 2, 1, 2. This is my 1, 2, representing my A. Since this is the first one, I'm going to use white. We have our 1, 2 over here. Then our B was 4, 2. So X is 4, Y is 2. We locate that over here. And then C is 4, 5. So 4, 4, 5. We have that over here. And remember, it was a triangle, you see. So we would have to what? Complete it by joining the points. So this is what I have here as my triangle. And then I'm going to do my label as well. So that I put my A over here. And then my B is also going to be here. And then my C over here. Now with that done, we go on to what? Our translation. The first one was over 90 degrees. And these are its coordinates, you see. So we are going to plot that. A1, B1, and then C1. So the first one, which was A1, was negative 2, 1. So negative 2, 1. This is it over here. These are A1. And then the second one, which was B, was negative 2. B1 was negative 2, 4. So negative 2, 4. We have that over here. And then C1 was negative 5, 4. Negative 5, 4. You have that over here. That is your C1. You see. So let me write their coordinates attached to them. After which we now join our lines. So I'll join this here to this. I'm going to join this to this. And then also this to this. You see. Now I would love to illustrate what has happened, but let's finish transferring all the points, then I'll come back to that. So for the 180, if you go back here, these are the points that illustrate the 180, you see. So let's come back here. You write the points down, you see, the 180, this one's here. So write them down so that we now come and then plot them here. So for A prime prime, that was negative 1. It means it's going to be in this quadrant over here. So we have the first point, A11 being negative 1, negative 2. So x equals negative 1, y equals negative 2. There's a point over here. And then that is A prime prime. So that is it written over there. Then for B prime prime, whose coordinate is negative 4, negative 2. So we have negative 4, negative 2. This is it over here. That is our B prime prime. Negative 4, negative 2. And then for the very last one, which is C prime prime, its coordinate is also negative 4, negative 5. So negative 4, negative 5, negative 4, negative 5. That is it over here. You see, that is for C prime prime. So negative 4, negative 5. Then what we do is we join this point, you see, because it was a triangle. So you take your ruler and join the point. Then for the very last one, let's quickly look at those points. These are the points here. Then now you can write them down. Then we do our location. So for A prime prime, we had it to be so for the last one, we have A prime prime being what? 2, negative 1. So 2, negative 1. We have that over here. So for A prime prime, we have 2, negative 1. Then that of B, the third, that of the B was 2, negative 4. So 2, negative 4. We have that over here. So B prime 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 is 2, negative 4. And then C prime prime is 5, negative 4, 5, negative 4. We have that over here. So 5, negative 4. Now with this, we now join all the lines. You see, so with this, we are done with what? All our transfer of points. And now to illustrate what we have done over here, I have highlighted this very first one. And I'm going to do all the rotations so that you see what has happened. So for the very first one, I've just added this line here so that we see how the movement is going to be. So for the very first one, which was, I think that was 90 degrees. Yes, so the first one was 90 degrees. Let's look at what happened. So this is a figure, you see, and it's rotated at an angle of 90 degrees. This is how a 90-degree rotation will be like. You see. So to illustrate what has taken place, this is the very first one over here. Okay. So I have the yellow one being 90 degrees, this here being the 180, and then we have the 270 here. So if I rotate this figure about a 90 degrees, this is how it looks like. But remember, we said it should be about a fixed point. So this imaginary, sorry, this line I've brought in here should align to the center. We said the rotation should be about the center. And you see, as I have aligned it to the center, you see it fits perfectly what the calculation gave us. You get it now? Okay. So for, if we go back to the position and then we try and rotate it about 270. So this here is a 90, sorry, about a 180. So this here is a 90 plus another 90 gives us this. And if you bring that here, you see, about the origin, it fits into what we drew over here. You get it now? Then for the very last one, which was 270. So let me fix it back as it was. Then 270, it means we are rotating a 90. This is our first 90. Then rotate another 90 and then another 90 as well. And this is how it's going to be like. So if I bring it here, you see it fits perfectly into that. So basically, this is how we go about rotation, you see. And using the formula is very straightforward. Just understand the formulas involved and you'll be good to go. So on that note, I'll give you some exercise you can try on your own just to test your understanding. This video has actually been very long, so I'll just end it here without going much further. So you have a try work here. Now you have triangle ABC with all these as its coordinates, and then square EFG with these as the coordinates of your EFG, and then DF, and then whatever it is. Now rotate the figures above in 90 degrees, in 180 degrees, and then also in 270 degrees. You have to do that about the origin. You have to do it on a separate sheet. So I mean, you do the triangle on a different sheet and then the square also on a different sheet, showing the 90 degrees, the 180, and then the 270. But first, you need to plot out the figure itself. I do hope this video was helpful. If there's anything, you can let me know at the comment section and I would address that. Now in our next video, we are looking at enlargement. Enlargement is not a rigid motion. We look at the enlargement and then we do some examples on it. Stay safe.